Hello everyone, this is the RatFatLab Cafe. It is supposed to be a place of joy, but as you can see, it's total chaos. We've got errors, the baristas are panicking, and the whole system is collapsing. Now is the time that we take action and solve our problems. So, we built a solution from the ground up, an automated drink ordering and billing system, developed as our complex computing project. So, what is it? It is a simple C program that stimulates the entire ordering process. It lets a user select a drink, choose a size, and add an optional sweet treat. The key is that it uses arrays to store all the menu items and prices, calculates the total bill with a 10% text, and displays a clear final order summary. The goal was to stimulate a real-world cafe operation. By using a console application, we can replace the error-prone manual billing with a system that calculates the subtotal, applies a fixed 10% tax rate, and gives a perfect final bill every time. To do this, we had to establish a clear methodology, exploring the how from the data and tools to all the way from the core algorithm. So our data set was the menu itself, the drink names like Spanish latte, their prices, the size options, and the text price. The tools were pure C programming using the Dev C++ IDE and the GCC compiler. Now let's move towards the algorithm and pseudocode for this project. The algorithm is straightforward. Step 1. Start by displaying a welcome message in all the menus. Step 2. Get the user's input, their choice of drink, temperature, size, and sweet. Step 3. This one is very crucial. Validate. If the input is invalid, we set a default. No crashes. Step 4. Calculate the total, apply the tax, and at the end, display that by the final summary. Okay, so now we're gonna see the flowchart for this code that we generated. The flowchart shows that logic visually that we actually implemented in our C code. For every input drink, temperature, size, and sweet, there is a check. Like, is the input valid? If yes, proceed. If no, it sets a default, like default drink or default size, which prevents the program from ever crashing. It just keeps moving until it retrieves the prices from the arrays and displays the final bill. Our objectives were very clear on how to work on things to make the cafe run smoothly. Automate the billing and generate accurate itemized bills. Our goal was to apply our programming fundamentals in C, specifically using arrays, loops, and switch statements, which are also known as the control flows, and the overall simulation had to be simple, structured, and user-friendly. And the expected outcome was a functional console-based system that works.
Things are a total mess at the RatFatLab Cafe. We've got baristas running around completely confused. One's just holding a baguette and the system is a disaster. We're seeing all sorts of errors that just crash the ordering process. It's a chaos. One barista seems to be stuck and can't even process an order. This C code implementation is so critical. We had to build a system from the ground up to fix this, and it all starts with organizing the menu and validating the input. We have 5 elements in this code. The first one is array, the second one is input or validation, where we take input from the user. The third one is calculation. The fourth one is constant with a 10% tax rate. And the fifth one is output, where we display the order summary. In this code, first we define everything clearly, no more guessing. We're using arrays to store all our drink options. We have the drinks array with items like Spanish latte, iced brown sugar espresso, tiramisu latte, and strawberry matcha. And we also have a parallel array of drinks prices holding their cost from 600 to 750 rupees. We do the exact same thing for sizes small, medium, large, and for our sweets like lemon tart and almond croissant. So when a customer walks in, the program first welcomes them to the RatFatLab Cafe. It then uses a loop to automatically print all the available drinks, showing the name and the price for each one. And it simply asks for choice 1 through 4. Now here's the part that stops the chaos. To prevent those real-life errors, we have input validation. If a stressed barista accidentally types in 5 or 0, the code checks it with this if statement. If immediately prints invalid choice, and this is the key, it defaults to the Spanish latte. No crash, no fault, the line keeps moving.
Okay, so here's the final part of the code that pulls it all together. After picking a drink and size, the system asks to add a sweet. It shows a clean list with prices just like before, and critically, it has the same validation check. If you enter an invalid choice, it just defaults to no sweet, so the program never crashes. Now, this is where the magic actually happens. To get the price, it takes the user's choice, say 1 for the first drink, and subtracts 1 to get the correct array index, which is 0. It does this for drink, size, and the sweet. Then it calculates the total, adds the 10% tax, and gets the final total at last. And this is the payoff. All that validated data is used to print a perfectly formatted order summary. It lists the drink, the size, the temperature, and the sweet, all clearly listed with the correct prices. Finally, it shows the subtotal, the 10% tax, and the final total bill. It's clean, it's accurate, and it's reliable. But absolutely, it wasn't always this easy. Now, this was a scene at the RatFatLab Cafe before. Total system failure. Baristas were in a panic. The process was broken, and the computers were all just down. Now, when we dug into the code, we found some critical challenges. The biggest one was an off by one array access error. C arrays start at index 0, but our menu started at 1. This meant our early code was constantly trying to read garbage memory or just crash the program entirely. The fix we found was to always use choice -1 to map the user's input to the right index. We also had a logic bug. We were trying to validate input, but we had accidentally used the wrong operator, a bitwise OR instead of a logical OR, which led to unstable validation. We had to correct all of our logic to use the proper operator to make the checks rock solid. Now that those core bugs are squashed and the system is stable, we can actually think about the future and scalability. We have 3 major enhancements planned for the next phase of development we have. So the first thing we have is multi-order functionality. Right now, if one customer wants, let's say, 4 drinks, we have to restart the program 4 times. This is wildly inefficient. So therefore, we need to implement a do-while loop to create a persistent transaction that lets the user order drink after drink before finally running the calculation. This will be a huge win for speed. Second, we have database integration. Tracking sales history isn't just about showing a total, it's about business intelligence. We need to connect this to a real database like MySQL or SQLite to store daily sales and track which drink is the most profitable. This lets us manage inventory and target our marketing. And finally, we want a new interface. While the console is functional, we plan to transform this from a simple terminal program into an interactive website using HTML, CSS, which would also let us save receipts directly to a file. Now, in the end, this project was a huge success. It demonstrates how to automate billing and reinforces the core concepts of C programming. It simplifies this manual work, ensures the prices are always accurate, and serves as a perfect foundation for building even more advanced applications. And well, this is the RatFatLab Cafe today. From system failure to system ready, there are no more crashes, no more chaos, just happy baristas and perfect orders every single time. The code holds, the orders fly out, and the